Okay, we are in the second half of the stream. Hopefully, it's going to go a little faster than the first half. We were writing docs in Elixir. So I'm going to. Things that we didn't do last time when I had Quinn on. Remember, we started building an evaluator, a naive evaluator for the Datalog language in Rust. And it was basically just like we built some Rust data structures and then we manipulated them using the standard algorithms. So we left it at the point where it kind of worked, but we didn't get a lot of the niceties that we had in the Elixir version. So I do want to point out. So this is the repo, by the way. It should be public, but I also have an implementation of it in Elixir. So this is kind of what we based it on. There's also this blog called The Essence of Datalog, and I'm just going to go ahead and open that in a tab. And yeah, and so we kind of got to the point where it sort of worked, but we didn't get a lot of the things that I had in the Elixir version. So first thing I want to do, if you're not familiar with this trait, display. So I think we did derive debug on a lot of these things. So we defined all the types that are needed inside the evaluator, the interpreter, if you will. But they're just structs, right? Like there's a rule struct and there's an atom struct and there's a term enum, which is a an algebraic type, and then we have some wrapper structs for some common types that are in the standard library. We define a program as a vec of rules. We define a knowledge base as a vec of atoms, and so forth. And a substitution is so what I really love to do is I really love to be able to take. We're not need much of that. So if we go down to the tests, I think this really shows in the tests. So we built this example, and this is the syntax. This is Datalog syntax in the comments. And we kind of faked it with some Rust. So what I'd love to do is be able to take this set of rules, right? And pretty print it back into the Datalog syntax. So that's what we're going to do with the display trait. So we're no longer in Elixir, we are in Rust land. So let's look at the display trait. All right. So what it requires you to do, it requires you to implement this format method. It takes self, so that in our case will be something like a program or an atom or a rule or something like that, and then it gives a formatter, and what you're supposed to do is write how you want this to be formatted in, like, as if this formatter were a stream that you're writing out to a file. But it could be print line, it could be format this to a string. But this is basically what you do. You say write, and then you give it some kind of format string, and then whatever you want to put in there. And we'll do something like that. So let's start from... and there are some macros we might want to look at in the format module, standard format. The main thing here is this, right? But this is a format it to a string. If you use the write version, then you give it the stream to write to. And there's also debug. There's all sorts of things about formatting numbers. We don't care about that right now. Not localization, right? Okay, we don't need to escape things necessarily. There's no curly braces in Datalog, so we're probably fine there. And then we may on some of them want to do debug. So let's start from the bottom up. I think that's going to be the easiest way because otherwise we're going to get a bunch of compiler errors like this thing doesn't implement display. So our most basic thing is term, which is either a variable or a symbol. And a symbol in our case is well, let's so a variable would be something that is an unbound value, and that will be unified later as we evaluate. Symbol is in our case just a string. It's like a double quoted string. So let's put a use up here. Standard format display. Okay. And we're going to impl display for term. And we'll use the implement missing members so that we get and let's replace qualified path with use. Yep. That's not what I wanted. Here. Oh, well, actually, no, let's just leave that because we maybe use result, which is this is a type alias of the core result. And we actually will leave that in there. Okay, so for a term, we need a match self here. So it's either a variable or a yep, it's either variable or symbol. So we'll use the fill match arms. That's really nice. So for a var, this is v. We're going to say a write. So this is similar to the format macro, but we're writing to that formatter. We just want to print out the string. And actually I can do it like this because it's a local variable. That's easy enough. And here we're going to write f. And let's say the symbol is s. I'm going to do debug. And like this is just because we know this is a string, the string implements debug. So we can format it with the debug specifier for string and then it'll print out with quotes. This way I don't have to manually go in here and go like backslash double quote, etc. In this case, so we know variables will be printed without quotes around them. Okay, so let's make a quick test. Let's say display impls about that. And assert EQ. Let's say var format. We're going to have, so this is just implement, this is just asserting that we can do a term var.toString. Okay, and then we'll do something similar. And these are going to have to, I'm sorry, we're going to have to borrow those because this is a static string and this format returns a string. Like capital S allocated on the heap might deref to stir, but that's a lesson for a different time. So here I'm going to have to use the backslash because I'm not a string. Okay, so this is going to be not a var but a symbol, a string. Okay, and then let's run this test. Okay, It failed. What did it fail on? Test example, explicit panic. Okay, so that was just so we would use debug. We had that in there from before. So let's go up to example, and then the solve returns a knowledge base. Yeah, let's just remove this panic, and this would be like if we want the if we want this test to fail. This is just so we can run the example. If we want this test to fail, to check our work, we'll probably need something a bit more interesting. And there are some things that we didn't include in this that I want to get to. We probably won't today. We're just going to focus on getting these things pretty printed. Okay, so we have let's run the tests again. Okay, everything passes. So we've determined that we can print terms. So let's ratchet up one more level away from terms. Okay, so let's impl display for Atom. Okay. I love those Rust Analyzer autocompletes. By the way, hint hint for our friend Mitch Hanberg, please make nice autocompletes for Elixir. Thanks. Okay, so when we have an atom, we have predsim, which is the name of the atom. So in our example, maybe if we like split down and we can scroll down to the tests in here. And let's get that out of the way. We don't need that. So in the tests, we have stuff like this, right? And sometimes you use debug, or it's like bits like this. This is an atom as well. I'm sorry, no, this is an atom. An atom can be part of a rule, right? So rule has the bodies. So this before the period is an atom, including the period is a rule. That's saying this is a rule with no body. So for atoms, we only care about the name and then the list of arguments. So if this were debug, we would have stuff like debug list. But you know, because it's got these, the formatter. No, we might have that debug list. The problem is we don't want to invoke debug for term. Okay, so we know that we need the predicate symbol in the output. So let's do this in stages. Let's do write f, and we're going to say self.predsim. And we're just going to put question marks on the end of that. So note that returns. So write may return. It's going to return a standard format result. And if we want to bail early, we can use the question mark. So that will mean at the end here we'll either have the last write statement or we'll go do like that. So I'm going to go ahead and put in OK. And then what we can do is so The problem is going to be printing the separators. Let's look at iterator. Maybe we can do something with iterator intersperse, if there's something like that. Intersperse. Nightly only experimental API. Boo. Shoot. Okay. I hate it when that happens. So potentially what we could do is right. So let's do let feel. Okay, so if let's only go into this branch if self.terms is empty. If it's not empty, um, and then we will do. So we'll write first of all the opening paren because we know there's going to be terms there. Okay, and then of course we'll need to write the closing paren at the end. And what I'm thinking we'll do is we want to make sure that these are separated by comma space, so that you at least get something that looks reasonably like this. They're not going to be column aligned. We don't care about that. So let's say let terms self terms iter map. We're going to do flat map actually. Flat map. Okay, and this is going to have one term t. And then we're going to do, let's return a vec. Yeah, it's going to be a comma space, and we're going to do format. There's a rationale for me doing this. Bear with me. Because format also also can return okay or error, right? So we kind of, or does it? No, yeah, I think it just panics. Never mind. It just panics. What we want to do is collect. I'm trying to be too clever. Okay, here's what we're gonna do. We're gonna do it the dumb way. Okay, for term in self.terms iter. We want to borrow. Actually, probably just let's try self.terms first. Okay. And then we want to do if not is first. Then we want to write to f. And this, I'm sorry, this is a macro. I don't know why I didn't put the macro everywhere. Okay. And a question mark. And then what we'll do is write term. Okay, so this is saying we'll only write the separator if it's not the first time around the loop. Now, actually, this is probably bad. Let's do iter enumerate. That's the cleaner way to do it. And enumerate, I don't remember which side. Enumerate I implements iterator. Item is usize. So the position term. So here we can do if position not equals 0, right? That's better. You know, the funny thing about Rust is sometimes like I want to do this clever you know, my elixir tendencies pop out when I'm writing Rust sometimes. I want to do something clever and it's like, just write a for loop and have a condition on the position within the loop. Okay. So, so this is ensuring that we have a comma and a space between each term in the list of terms, and that we are wrapping them with parentheses. Okay, so I'm gonna close this split, and we're gonna run down here, and we are going to do something like this. And we're going to test it in our display impulse. Okay. We're going to say, let's put this on the right side, format. And let's just pull one of these. Okay, so what we want this to look like is advisor, and it's going to have a quote, Andrew Rice, comma, space, oops. Now I could probably do raw strings here, but we're not going to do that. We're just going to say, this is what this should look like. If we implemented our display trait correctly, let's also make another case. So the empty, we want to test, let's say is true. And this is an atom pred sim is true to string. And terms is just an empty vec, right? Okay, and that's not going to be equal. We would need to format that. Format. Okay, that's toString is a method. Okay. And then let's also do, let's do another case. I'm just going to copy paste this so it's easier. Let's say singleton. And let's use a variable. Predsum is singleton, and the terms are term var v. And that needs to be a string, an own string. Okay. So this is what our atoms should print out like. So let's start to annotate this. Let's say terms, atoms, right, I need a semicolon. Oops. Come back. Okay, so cargo test. It passed. So we know we're printing that out correctly, at least if as long as I typed the actual string correctly. So that's cool. So we know that we can do that. We know we're printing out vars correctly in that spot. Let's move on up to rules, and then we'll wrap up the stream. Um, maybe we'll do programs really quick. I think it's probably going to be really easy. Um, okay, so we have display for atom. Let's implement display for rule. And what we'll be able to do is take advantage of the fact that we have display for atom. So the head will be really simple. Okay, let's implement missing members. Yay. Okay, so every rule is going to have the atom at its head. So if we're looking down here at the example, so it's either this, and so remember we were saying an atom is this, and then a rule, that dot. So that dot separates rules in the program. Now you could do them all in one line, but it's not conventional, and we kind of want to do pretty printer here, not just a print to the lowest common denominator. So what I want is every rule to be terminated by dot and a new line. But if there's a body to it, we have between the atom that represents the head of the rule and the atoms in the body of the rule, you have this colon dash. And then if you have more than one atom in the body, they're separated by commas. So we need to kind of do something similar to what we did in the atom with this comma separation stuff. The other part is that even though this is displayed on one line here, I personally would prefer it like this. Maybe 2, maybe 4 spaces. Let's do it with 2 spaces, and then it'll look more like, let's see here, more like this, right? So with one atom on each line of the body. Okay, so similar to, let's start with returning OK with the empty tuple. And then we at least compile. We're not using that F, but so we're going to start with right and we'll say self dot head, right? Because and we'll put question mark. We got to put question mark after each one of those so that it returns the error if an error happens. Okay, so self.head is the atom that's at the head of the rule. And then in here we'll do something if the, so we'll like write the body. Let's just leave that there. At the very end we're going to do F and we're going to say dot/n. So in this case, we don't need to return OK. If we got to this point, the result of write, it will be a standard format result. So the return value, rather, of this write macro will be standard format result. So we're OK there. And that way we get, at the very least, the atom that is the head, and then dot and/n. Okay? So now we get the fun of writing the body. So we'll do something similar. If self.body is empty, okay, and then we'll do something. So here we know that if we have a body, we need to write the head body separator. And since I like that that new line on the end of that, we'll write :/n. Okay, :/n. So that's the separator between the head and the body over rule. And then we'll do something similar to what we did on here. So for position, say for position atom in self body iter enumerate. And this one is a little harder because we only want to write the separator if we know there's another element coming. So let's say if position is self.body.length minus 1. Okay, so we're gonna write just the atom first. Question mark, and I need that macro. Okay. There's probably a more elegant way to do this. And then if we're not at the end, right? And since we don't have the iterator inside the loop here, I can't like peek, say, do we have any more? So we're just going to rely on the position. Why don't we just compute that outside? Last position or last atom position. And we know that this can't underflow because we've already checked if it's empty. So if it's not equal to that, then we will write our separator, comma, there we go. All right, so except that we made an error here. I didn't indent. So I'm going to put 2 spaces in there in front of the atom when it goes on to a new line. Let's scroll down to our tests down here, and let's copy this into our test for display. Okay. So now I need to go, I should have gone back up. We need to get this rule that we defined, right? It's the ancestor rule. Where did it go? Here, here's an example. Academic ancestor. Okay, so we'll just do one. We'll do 2 tests separately. Okay. Let's copy both of them down into here. Okay. So we're going to say assert equal, and we want it to look like this. Without that. Excuse me. And we want 2 spaces. This is not going to be as intuitive because we're not breaking this onto multiple lines. And that's rule. We need to put the paren on the outside of that. Okay. We want format. And that should have a /n after the end of it. And we need to borrow it so that we get a stir and not a string. Yeah, let's just do that. And then it about unmatched bracket. Oops. Unmatched closing delimiter. Oh, we need another paren here. Okay. So we've got the rule, academic ancestor, this first one, advisor, XY. Okay, so it should format like that. And let's copy this one down here, do something similar, and then we will wrap it up for the day. We might do formatting of programs because it's really trivial. The testing is not trivial, but the implementation is. I just don't know how much longer I want to go and how much longer that you all can put up with this. So we'll see. All right, so we're going to say format. Come on, Sean. Okay. Right. Okay. And now this is going to look like this. /n, 2 spaces, advisor, x, except we need to remember that in our formatter, it's not so compact. It puts spaces after the terms inside the atom. So we need to make sure that we put terms in there. Comma /n, 2 spaces, academic ancestor, yz dot /n. Okay. Woo! Let's run this test and see if we broke it. It worked. Okay. Luckily, this is a pretty easy format. It's just yeah. So what I actually want to do is let's go ahead and do display for program, because that's I'm not going to do it for knowledge base yet, which is just vec of atoms, right? That's kind of an internal structure that's used during evaluation. Program is like, here's the definition of our thing. That's the thing we really want to print out. So let's impl display for that, and it shouldn't take very long at all. For program. And this is another reason why we actually put these wrapper structs on here, is because if you said pub vec rule, you wouldn't be able to implement display for that. Because vec over any type doesn't implement display. Vec is defined in another crate. Display is defined in another crate. So if you put the wrapper program here, the wrapper struct around it, this is a 0 overhead struct, but allows you to put methods on it. And define traits. So yeah, Datalog, thank you for your comment. Datalog is fun, and it's sort of like, it's a really interesting research language, but also I think it kind of teaches you about how databases can answer questions, and also very limited sense of how logic programs like Prolog or Miniconrin or something like that answer questions. Anyway, let's go. Thank you for your comment. Let's implement display for program as the last bit, and then we'll print out the program that we have in our example test and see what it looks like, and that'll be a fun ending for the stream. Okay, so a program is just a vec of rules. So we can say for rule in self.0. So when you have a tuple struct, and we'll say, okay. Remember, we have to return a result type. So if we do, what's wrong there? Okay, we'll borrow. and then we don't use rule. That's to be expected. Okay, so this one is actually simpler than any of the others, and this is we write to the formatter rule, and then we put question mark on there so it bails if anything fails in the middle, and that's it. Easy peasy. I am not going to write a test for this, or maybe what we could do. Actually, let's make a real quick test. This is actually just should be pretty simple. So remember we have this stuff. We can just take the contents of these two strings and smash them together and put these two rules inside a program and then call it good. So let's do that real quick as our test. And so we're going to take this. This is what our program should look like. And let's take this rule. Oops. We just want to copy it. So we'll say program. No, don't overwrite that. Let's put that in parens. This is a program. Okay, so now we have it as a vec of rules. Right? Okay. And that is the end of our program. And let's put the other rule in there. And it did not format. What have I got going on? What have I got going wrong? I'm going to manually indent these. Yeah. Okay, so that matches up with that rule. We have a new rule. I'm probably missing a delimiter or something somewhere. I thought copying and pasting it would be enough, but it wasn't. Okay, that's the end of that rule. Let's put a comma there. And then we have that. And because my text size is so big for the stream, I can't. All right, let's see what happens when I run cargo test. It's probably not going to compile. Oh no, it worked. Okay, that's weird. Let's run cargo format just to be sure. Yeah, fine. Did it reformat? Yep. Okay. I don't know what was going on. That's a really big expression. Okay. So let's jump up here to the example, and we're gonna put the. So this just tests that. This just tests that we solve things correctly, and I think we're gonna. Let's try it without. I think we're gonna have to insert that panic so that we get the output to print to the shell. But I want to look at what this looks like and make sure that our program is transcribed correctly. I trust Quinn a lot. I think it probably is, but let's do it. Okay, so let's do test example. And it's not going to. Okay, so panic. Okay, so here is our output. And it prints pretty dang nice. How about that? If I were inclined, and we have more time today, which we don't, I would probably go and do something like, hey, let's parse Datalog into our data structures, and then pretty print them and parse them again and make sure that we get the same result. Um, that would ensure that we got the correct formatting, and that we have sort of a round trip, property test type thing. Cool. So that looks pretty nice. That looks very similar to the program that is in the original blog post that this project is based on. So that's cool. Um, yeah. All right. I think that's a good place to end the stream. Let's make a commit. I'm not going to write the README yet. We'll do that on a different stream. Add display implementations for the primary um, data structures. And let's push. So again, if you want to look at this in whole, I know it's kind of hard to see sometimes when I'm scrolling through. I'm jumping between the tests and the implementation. Um, but it is available. So that was the Elixir version, which is also a fun read. But the Datalog Rust version is here. Sean Cribb's Datalog Rust. I'll probably pin this to my GitHub profile. And I think that's about it for today. Thank you for coming, and I'll stay for a few minutes. If you want to drop any questions in the chat, I can always jump back to the code and we can talk about that. Otherwise, have a nice Sunday, and we'll see you next week. Well, thank you so much for coming, Marsh Ray, and hope to see you next time as well. Same time every Sunday, 3:30 p.m. Central Daylight Time or Central Standard Time when we go back to Standard Time. Whenever I post it, I always post an every time zone link so you can look at it in your own time zone. Please refer to that if you're confused about when I'm going to start. All right. Everybody have a lovely weekend. See you next week.